Good evening, good afternoon, good morning, everyone. Welcome to our next webcast on the Internet of Things. Mike, are you ready?
I'm ready, Lester.
Okay. Well, first of all, let me welcome everybody. This is the first of a four-part series Mike and Tom are going to be doing on Informix and the Internet of Things. There's been a lot of hype about this. What we want to do is show you some very practical examples of how this can work and how this works with an Informix database. So I'll let Mike take it away, and there will be time for questions afterwards. If you see the chat button in the top right, and you have questions, please type them into the chat button. That way, at the end of the presentation, we'll get everybody's questions and try and get them all answered. Also, just so everybody knows, this is being recorded, and we should have a replay up. It may be 4 or 5 days before it gets up on our YouTube site. So, Mike, take it away.
All right, thank you, Lester. So I'm Mike Walker from Advanced Data Tools, and this is the first webcast in a series of 4, and this one is an introduction to Informix and the Internet of Things. So the next webcast will be in a week's time, and I'm going to go into a bit more detail about things like time series, and that'll be followed by another 2 webcasts that Tom Beebe will run about setting up an Informix database server on ARM, and also just the installation of Informix on ARM, which is going to be more of a general installation of Informix. Okay, so this particular webcast, though, I'm going to start off with a brief overview of what Internet of Things is all about, IBM's involvement with Internet of Things, and then show you a demonstration of some sensor data and how it can be pushed out to the cloud and how you can view it. And that's a practical demonstration using little sensors that I put together. I'm going to give you an overview of how all these pieces come together to create an Internet of Things solution, and then delve into some of the details of how I created these sensors with microcontrollers and the role they play in connecting your sensors to a database. I'm going to show you an example of an Arduino, which is a microcontroller board, and reading some temperature values from a temperature sensor, and then show an ARM-based computer, actually a Beaglebone, working as a gateway. Then I'm going to give a brief overview of installing Informix on the Beaglebone, and go into how we do the wireless communication using XBee radios. As I say, these are just examples of how I've done it, and I think all together they'll create a good example of Internet of Things. Okay, so what is this Internet of Things all about? It's really about connecting the physical world and the digital world. So the physical world being sensor values usually, or any kind of data points, and then collecting that data and creating a great big network of them where you can view that information anywhere. Okay, some examples of Internet of Things. Some of these you may have heard of. Smart meters are a big one. Around the world, utility companies are putting in these smart meters, which allows them to monitor real-time energy use, and even the homeowner or a business owner to be able to monitor their own energy use at any point in time. Virgin Atlantic, with their new planes, they're collecting data from sensors all around the plane, and a single flight can end up with ½ a terabyte of data. And Disney World, if you've ever been there, and there's a magic band, and that allows you, it's just a little wristband that allows you to get into your hotel, buy lunch, do all sorts of things, and Disney can then collect data on the movement of people around their park. Now that's commercial applications, but in terms of consumer examples, there's all sorts of things now available. Now this is a photo I took in a retail store of a end display there of a whole bunch of Internet of Things devices. It's sitting there right next to all the bed linens and stuff. But just in this one display, you've got things like connected light bulbs, a thermostat, and you've probably heard of the Nest thermostat, where you can check it and change it just on your smartphone. You don't even need to be anywhere near your house. In this display, there's a garage door controller, a door lock, a power strip, all sorts of things, including a piggy bank even. I mean, some of these things are getting reaching a little bit, but it's still an example of an Internet of Things device. Now, all of these things you can connect to with your smartphone, and you can control and you can monitor. So just by seeing how this is in a local store, you can see how Internet of Things is being just pushed into the consumer market. It's everywhere. There's a few reports on the future of Internet of Things and how many devices we're going to have connected. And they vary from 26 to 30 billion, and there's probably even more bigger numbers than that. But regardless, and then over the next few years, there will be billions upon billions of devices all connected to the Internet, all collecting data, monitoring data, pushing data around. So why do we care about this? Well, it's a fundamental change in the way people are going to expect to get their data now. We're going to be able to view things remotely, monitor things remotely, and change things remotely, all through our phones. Power companies will be collecting all of this data in real time or close to real time, and the big thing is how much data this is really going to involve. There's a huge amount of data that's going to be collected. So IBM and Internet of Things. So IBM have done a number of things that they're doing to in the Internet of Things market. One of them is an Informix database, which is one of IBM's products, and that Informix database has been chosen as IBM's choice for the Internet of Things. And part of this, one of the things so good about Informix is the time series, and I'll come on to this in the next webcast, but just very simply, it's a very efficient way to store large amounts of sensor data. You can run Informix on small footprint, cheap hardware, like an ARM processor, Intel Quark. They're also establishing partnerships with different companies to include Informix as part of their offerings. And also, Informix is now available as a Docker image, so you can just put that on the Docker platform and have an Informix database up and running really quickly, ready to try. Also, there's the Internet of Things Foundation, which is a cloud-based repository for Internet of Things data. And Node-RED, it's a very cool application that allows you to put in flows of data, certain data from this place, what you want to do with it. It works with tweets. You know, if you get this tweet, do a certain action, and you can just manage that flow through a web browser. Okay, let's get on to a demonstration, and this will make things very clear, I think. So I'm going to show you now. Bring up my webcam. So when this displays, you'll see two sensors. These are two boards. The one on the left is a wireless sensor. It's a temperature sensor, and that's all it's collecting. The one on the right is a more advanced sensor where we've got a temperature and humidity values being collected, a compass on there, there's a switch, a light sensor, and a little turning knob. So those are my sensors, and these things are sending data over to this orange box here, which is it's got a little ARM processor in it. So it's a Linux-based computer. You see it's a small thing, but it is just collecting all of that data wirelessly and storing it in a database, okay? And we can view the data coming in just with PuTTY. So here's all this data coming in from one of these sensors, and if I was to adjust some of the settings on here, if I turn this knob, turn this dial here, whoops, let's try and get that. or if we change the direction, we'll see that these values are changing at the bottom here. Now the dial went down to 0, the compass direction changed. So this is all the sensor data coming in, and it's being stored locally on the ARM processor. Okay, and we can view that data through a web page. I'm just going to bring this up. Oops, that's the one I'm going to show you. So I'm reading that data from the database and displaying it on a web page. Okay, now all of this is local. I can show a graph. I can run any analytics I want locally on the Beaglebone in this case. Okay, but what we're also doing is taking this data and pushing it out to the web. We're pushing out to the cloud. Once it's in the cloud, we can start reading that data from anywhere in the world. So here's some values that I've just retrieved from the cloud, and they're updated in close to real time. And so even though it's on a web page, this data's coming from the cloud. I can plot graphs on it, on that data. And even better, if I bring a webcam again, hopefully this will display. I'm putting this, I can even retrieve these values over the phone. And that page is not being updated. Let me just disconnect my webcam, connect again. We know how live demos go, don't we? There we go. So these values are also on my phone. So if I was to change any of these sensor readings, for example, by putting a fancy bit of cardboard over the light sensor here, we should see how those values changed. How the light value went down. So remove that. Get more light there. And these values should, I'm updating like every 15 seconds, I think we're pushing this up there. So within a few seconds, we should see that light value jump back up again. So what we're seeing here is a great example of Internet of Things. We've got the sensor data. The sensor data is collected over here. It's being stored locally, then pushed out to the cloud where we can access it from anywhere. And the same cloud has APIs where you can pull that data back down and use them in your own applications, or in my case, I'm putting them onto a web page. So here's my own web page where I've got a webcam mounted under my deck, but I'm also pulling these same values down from the cloud and displaying them on a web page here, together with the graphs, all provided by APIs. So you can see how, for example, the light level changed at nighttime and how the temperature has changed over time. Okay, so that's my example. Let's go back to presentation. Okay, so that's the what. That's what Internet of Things, or an example of Internet of Things. But how do you get there? So let's look at how I put together this particular example. So we know there's sensors. There's sensors for everything you can imagine. There's all sorts of things you can get a sensor for. So what do you do with all this information? So you can take the sensor data and make local decisions, like if the temperature is too high, turn on a fan or something like that. But what you really need for a better analytics is to be able to store that data and collect data from different sensors where you can make more informed decisions. So you want to put that data, or you want to connect those sensors over to a controller or a gateway. From there, you can perhaps turn on an alarm or turn on the lights or turn on anything. You can actually make more informed decisions. You can take an action based on that sensor data. You can also push the information out to the web, out to the cloud where you can view it on a smartphone, and you can run local analytics. Okay, so that's a little framework there. So how does all this go together? So what are the technologies that we would use to implement such a thing? So obviously we've got the sensors, and I put this together with some microcontrollers, and I'll come onto that in a little bit. we need to have a wireless or wired way to connect to the gateway. We can benefit from ARM, having a small, low-cost, small footprint, Linux-based computer running on ARM. And that same ARM processor can run Informix, a full database, and we can benefit from time series, a really efficient way to store that data. And then we can push data out to the web. Okay, so a lot of things here that I'm going to go through one by one. So where do we start? And this is the dilemma I was in when I first started putting this together. You can get a simple temperature sensor. This costs like $1, but that's a little bit of electronics, and how do you go from there to a pretty graph, data in the cloud, that kind of thing. So this is where microcontrollers come in. So a microcontroller is a small electronics board, and its big, how it comes into play here is that you can use it to bridge the gap between the physical world, like the temperature, for example, and computers. You can turn those sensor readings into digital form that you can then save in a database or push out or whatever. And they really benefit from having these input and output pins. That's where you connect that microcontroller board to your sensors, to your motors, whatever. And they're programmable. So we're not just using electronics now to get what we want, to control what we want. We can actually write a program. There's a whole bunch of these microcontroller boards. Some of them you've probably heard of, but there are so many of these things now. What I chose to use was an Arduino, which is a simple board, costs between $10 and $45, depending on the version. There's small ones, big ones, different features. They're programmable, and it's a language based on wiring. And it's open source and open hardware, which means that there's plenty of different varieties and different clones around there. So here's just a few examples of Arduino boards, and you can see they go from pretty small to pretty big, and they've got different capabilities, different power regulators on them. Some are more specific, and a different number of ports, input-output ports. So you choose the one that's best for your application. Oops. Okay, so here's the one on the left here, this blue board, is an Arduino Uno R3, which is like a mid-sized board. But as I said, this is all open hardware. So here's just an example I happen to use, the SparkFun Red board. Price point's about the same. The footprint is the same, and notably all of these pins are the same. But you can see just from these pictures how the layout of the board is a little bit different. And one thing to note here is how the USB port is different. The blue one has a large, I think it's a Type B plug, USB, and then the red board has a Type B mini. So just one small difference that the guys who make the red board decided to do. But otherwise, they run the same programming language, and for the most part, they're interchangeable. Okay, so let's look closer at one of these Arduino boards. Again, I'm using the red board, but the Arduino works the same way, the Uno. So we've got these pins on there. And we've got digital pins, and we've got analog pins, and pins for power. So we can start powering other sensors from this board. So you program the Arduino with the IDE, and you can just download that for free. And then you can start writing your program, or they call it a sketch. Once you've done your sketch, you just upload it to the board using a USB cable. And here's an example of how these boards start communicating to the outside world. Within the programming language, you can define each of these pins as an output pin or an input pin. And in the example in the picture here, you can see how we've got a switch, which is in pin 2, and in the program, the sketch, you can see how that's defined as an input pin. This is a little press button. And then our LEDs, which we light up, those are, of course, output pins. So you can define any of the pins on the board as an input or an output. So you can see in this example, you've got the input as the switch, the output as the LEDs. And that's how we're now connecting the real world, the physical world of button presses and lights in this example, and we control them all through a program. Okay, I'm going to do a little example now of a simple Arduino temperature sensor. Let me bring up my webcam here. Move these guys out of the way. Okay, this is frozen again. Let me just restart this. Okay, so here's an example of an Arduino board, and all we've got plugged in there is one of those cheap little temperature sensors. And I bring up my Arduino IDE. I can compile the program, and then I upload it just through USB over to this board. Okay, done uploading. At this point, the program is now stored on the Arduino. I can close down the IDE. I don't need that anymore. I could even unplug this and plug it back in again, and that program has actually been, it is stored on the Arduino. It doesn't, as soon as I power it up again, it's going to automatically run that program. Okay, so let's see what it's doing here. I'm going to run a putty session. So if you can see that, we're now getting data from that Arduino board. It's getting a voltage from that sensor, and it's converting it to a temperature. If I go ahead and squeeze this this temperature sensor, we should see the temperature going up. No, that was good. Okay. Or not. Okay, so for some reason that's not working, but we would normally see that temperature jump up there. I had problems with these loose wires, that might be it. Anyway. Okay, so, but you can see we are reading temperature values from the sensor, and we're now using, getting this temperature and be able to deal with it on the screen here, or we could store it in a database. Let's close that down. Okay, so there was the example and the example of the sketch that we used. All right, so that was a simple Arduino sensor. Here's a picture of the sensor I showed earlier, where I've loaded it up with different sensors, and then you stack these boards together. They're called shields, and you can stack them up, and you can add all sorts of functionality, additional sensors, Wi-Fi, Bluetooth, all sorts of things, little servos through these boards just by stacking more of them together. All right, so what have we got now? We're reading sensor data, but what we want to do is we want to be able to store this somewhere. So we can actually monitor different sensors, maybe connect to the web and say, okay, what's the temperature, and make decisions based on that. We need somewhere to do that, and that's going to be a gateway. So we want a smart gateway where we can actually make some decisions. And I went with the Beaglebone for this, which is a very simple board, but it's a full-blown Linux computer. It's very small. Hopefully this will still work. Nope. So here's a couple of examples. Let me just bring this back up again. Nope. Oops. That's me. Try the other one. Okay, so here's a Beaglebone. It's a Beaglebone Black and a Raspberry Pi. So both of these are Linux computers, small footprint, low cost, and that's what I used for this example. Okay, so these things are powerful enough to run a full database. Looking at the Beaglebone specifically, it's about $55 for the latest version. It runs an ARM chip. It's got 512 meg of RAM. It's got 4 gig of storage built in, but you can expand that storage with a micro SD card. It's got Ethernet capabilities, HDMI. It does not have any built-in Wi-Fi or Bluetooth, but you can add that through the USB port. It needs 5 volts power. You can just power it from a USB also. And it ships with Linux already installed. There is no installation to do. And it's capable of running a full version of Informix, not a cut-down version, a full-fledged version of a database. So the setup, as I said, as soon as you get it out of the box, you can power it up with USB, and you can telnet into it, or SSH right into it. And as I said, you just run your normal Linux commands. Now, there are some additional steps that you can go through. One of them is you start off, get the latest version, so you flash it from a micro SD card. You can then configure the micro SD card for your additional storage, set up networking, update the packages, set up user accounts, just like you would with any Linux install. So why do we want a database on this gateway? Well, we really want to maintain a history of things. So we can go to it and we can run our analytics. We can run all our reporting locally. We can then make better decisions because we can pull from a bigger set of data. By having things locally in a database, we don't need to go out to the cloud to get stuff. We can, of course, but we don't have to. And now we're independent from an internet connection. So why Informix? So the example I showed is running Informix. Why Informix? Oh, Informix has a 20-year history. It's been around for ages. It's got full support from IBM, and this is not a cut-down database. This is enterprise-class database software. And because of that, it's reliable, it's robust, it's scalable, it's got great performance, and really easy administration. It's got all the things you'd expect from an enterprise-class database, including high availability, DR. It's got NoSQL support. It's got built-in JSON, BSON data types, as MongoDB APIs, all sorts of features you'd expect from an enterprise class and up-to-date database. But why Informix for Internet of Things? For all those same reasons I just mentioned. But specifically, there's Informix time series, which I'll come onto in the next webcast, but it's a great way to store huge amounts of data very efficiently. Informix is extremely easily to embed. You can run it with no administration at all. If you do want to do some administration, you can do it all through SQL commands. And it can now run on low-cost hardware like an ARM processor or Intel Quark. And this is the full version. There's no loss of features. It can run in a very small footprint, both disk and memory. And if you want to ship out an IoT solution on lots of these little boards, there are OEM licensing options for that. Okay, I'm just going to run through the steps for an install just to show. I'm not going to run it, but I'll show you the steps, show you how easy it is. First thing is to download the product from the IBM website. There's different versions, whether you're running on a Quark, an ARM 6, like the original Raspberry Pi, or an ARM 7, like the Raspberry Pi 2, or a Beaglebone. So once you've got that image downloaded, you install, upgrade or you install the KSH package, upgrade Java, copy the tar file over to your Beaglebone in this case, unpack the tar file, run the install. And anybody who's done an Informix install before knows how simple it is. It really is just a few steps once you kick it off, and before you know it, you've got Informix running on your $50 Linux board. You can administer Beaglebone, Informix on your Beaglebone with OAT. I've got an example of OAT running. Where is it? So here's an example. Oh, I think the resolution changed. Here's an example of OAT running against this Beaglebone I showed earlier. Okay, recently Informix has been made available as a Docker container for really easy setup. You can just go down, download the image, and it's the Informix Innovator C edition, which is free to use with some limitations. And there's 1 core, 2 gig of memory. But this is a great way if you want to start getting your feet wet with Informix and set it up really quickly. Just download the Docker image. Okay, so what do we got now? We've got our Arduino reading sensor data. We've got our Beaglebone, so an ARM-based Linux computer running an Informix database. So that's great, but we want to connect the two together, and we want to do it wirelessly. There's all sorts of options for this. We've got Wi-Fi, of course, cellular connections, Bluetooth. There's some other wireless protocols that are used by a lot of these consumer devices that you can get. ZigBee is one, and Z-Wave. Now, I started exploring ZigBee, which is a low-power radio device that you can use to create a mesh network. And so there's a picture there of the XBee, little radio module. And that's how I connect all my sensors to the Beaglebone. So you need an XBee on each of your sensors, of course, that you want to connect wirelessly, and then one on your gateway. You can configure these things really easily. You configure the radio on its own with AT commands. Going back a few years, I used to do this for modems and stuff. But then you can just set these values just through PuTTY. But then you want to use an API mode for more advanced applications. You can also use the XCTU application, which is free to download just to configure your XBee modules. Okay, so these XBees, they can be set up in one of 3 ways. They can be set up as a coordinator, a router, or an end device. The coordinator is you're only going to have one of those on your network, and that'll be connected to your gateway. So that's the destination of all of these other XBees. You have routers. These are always on, and they can connect to any other node in the network. And then there's an end device. The end device are great because you can set those to sleep. So they can be run on batteries, they'll last longer, and they connect to the router or the coordinator. So here's an example or a picture of what your XBee network might look like. A combination of routers, end devices, and a single coordinator, all communicating their data back to the coordinator. Where the mesh network thing comes in is that each of these devices can be used, or the routers can be used to relay data over to other routers or the end device. So that means you can start expanding your network by chaining these things together. So you can spread this network over quite a large area. But also, if one of these devices, one of these routers goes down, these radios, these XBees, will find another way, if they can, to get to the coordinator and send their data. So all that traffic will be rerouted. And that's done without any programming on your part. It's all accomplished by these XBee radios. So there's an application that you can use, the new XCTU, which can show how all of these devices connect together, can show your network. I have that running somewhere. Okay, I'm going to switch my resolution because I see that it's gone to high resolution again. Screen resolution. Lester, please jump in if this is not working properly.
So far, it was working fine, Mike.
Was it? Okay. I know there's a problem if I use too high a resolution. Is that looking okay?
Yes, that looks good.
Thank you. Okay, so here's a XCTU. I am going to move these out of the way. Going to unplug my Arduino board and plug in one of these radios. Just by doing this, I'm now connecting my laptop here to this same network that all my sensors are running on. So, all right, so now this is the radio that's plugged into my laptop. And I can get it to go off and find all the other sensors or all the other XBee radios that are part of this network. And it's going to go off and connect to them all. I'm just going to stick with that right now. Okay. And then this is what I like. We can start mapping these things. So here's the coordinator in the middle here, and right now it's discovered 3 routers and 4 endpoints. So these are all the little XBee radios I've got in my house here. We can see how they're all connected. And because all these endpoints are close enough to the coordinator, they're connected directly to the coordinator. Okay, I think that's kind of cool. I'm going to stop that. It's done with that. Okay, so you can also use that same application to configure your XBees remotely. So you don't, if they're out embedded somewhere in a hard to get to location, you can, as long as you can see it, you can, through the application, you can go and change the settings for it. Okay, so those are the XBee radios. Now you can connect to them. There's all sorts of libraries you can download to connect to them from the Arduino, from Python, from C, all of these kind of languages, so you can have better control over them. So on the Arduino, this is what we're doing. We used a XBee library, and we create a payload, and we send the data. So that's how the Arduino is wirelessly sending data over to the controller. It's sensor information. On the gateway, that's the Beaglebone, where I'm receiving that data. I'm running a Python script, which will just pull in the information or wait to read information and then parse that payload that it received and pull out the sensor data that it needed and the location it came from, that kind of thing. Okay, these XBees, because you can configure them through that application, you can set certain values to say, all right, wake up, send a value that's on a pin, and then go to sleep. Okay, by doing this, we don't even need the Arduino anymore. We've got a nice, simple sensor value that we can just transmit. Because we can then send the device or the radio to sleep for a while, it can run on batteries and last much longer. We can't do it. We can't use it to do anything too complicated. But for sending simple temperature data, then or simple sensor data, that's the way to go. So I've got a few of these. Here's an example of one of my prototypes, shall we say, where there's no Arduino involved. We're just powering the radio. And we've got a little temperature sensor on here. Just going to wake up, read the voltage, and send it. And then we'll interpret that voltage as a temperature on the gateway. So this is what we'd use for the end device on the edges of our mesh network. So these are the sensors I have in my house. The top 3 are, they all work that same way, where they don't need an Arduino. They just send temperature information. The one in the middle there looks quite menacing, but switches and lights. The one on the bottom there is the sensor I showed earlier, which is an Arduino-based one, again sending temperature, but also humidity values and a light level. And here's my outdoor sensor on the deck, just sitting there in my daughter's little playhouse. And it too is sending temperature, humidity, and light levels. Okay, so putting all this together. So we need an XBee on our Beaglebone. You can just wire that directly into those same header ports. You see those black rows of pins here. We can just plug it in there, or we could plug it into the USB, or in my case, I used a cape. Cape is the Beaglebone's shield, and they just stack on top. So there's the XBee module, and with an antenna on, and then I just put it in the little box. So that's my gateway. So now we're receiving data from these sensors at the gateway, and I can we can go back here. So here I limited this to just one particular sensor, but I can run my Python script here and show you all of these sensors and all the data coming in. So each sensor, or each XBee radio actually, has a unique address, which is displayed on the left here. And so that's how we know where it's coming from. And we can see the temperature data. And then for the Arduino-based sensors, we see humidity and light, switch position, a dial position, and a heading for the one that has the compass on it. Okay. All right, so now we've got all this data from all of these sensors, and it's coming into our base station, which are our gateway. And we can start now making decisions and doing things with this gateway. Let me just bring in, oh, where is it? Here. Okay. So here's one of my sensors. If I try and show this on the same screen. So now I can make decisions on here, or I can change the sensor values. So if I increase the temperature on this particular sensor, it'll trigger an email to me or trigger a text. So now this device here is not actually sending out the text, but it's sending its data back to the gateway where we've got our rules that say, oh, the temperature's exceeded a value, and trigger an alert. That's not working. I think my fingers are way too cold. So here's a better example I like. A lamp and my sensor here. So what I'm going to do with the sensor, I blow on the humidity sensor. And hopefully this will work. And this should trigger or send data back to the gateway to trigger an alert. Now, you may not be able to see on the webcam, but the light just came on. Okay, so here's an example where this sensor data is interpreted in the smart gateway, and it then is used to trigger something. In this case, we're turning on a lamp. Okay, so and that you could imagine that we could do more than turning on a lamp. We can do you know, to open a window if the temperature got too hot, or turn on a fan or something like that. So again, that lamp is controlled through, there we go, just turned off. That lamp is controlled through another wireless device. It is not connected directly to our gateway. And I can show the example of that. So the way we did this, we're using another XBee radio connected to a little board, and we're simply saying, hey, we want to turn something on, turn pin 1 on the XBee to on, so power that pin, and then we can use that to trigger a relay in which the light is plugged in. And this is all it is. We've got our little XBee powered through batteries, and I'm using a relay inside a commercially available relay gadget, but that's all it is, a relay. It's good that it's in a box so I don't touch it, and I can power a mains powered device from the gadget. Okay, so now we've got all these sensors. We've got Arduino-based ones and simpler XBee-based ones. We've got an ARM-based Linux gateway running a full version of Informix, and we've got all our data being transmitted wirelessly. We can receive the data. We can trigger actions, whether it's emails, turn on devices. But what are we going to do with all this data? We really want to store it in that database, and we want to use time series for that because it's just so efficient. We want to store it in the database to keep a history, and then we can pull that data out to run analytics and push it to the cloud, where we can access that same sensor data from anywhere. Okay, now that's the subject of the next webcast, which is on June 2nd, a week away, next Tuesday. And there I'm going to be describing time series, what it's all about, and how to set it up, just a simple regular time series, and then how I set up the time series for the sensor data. I'm going to explain about the virtual table interface, which is a great way to access that time series data, make it look kind of relational. And then how to display that data, or an example of displaying that data on a web page, and also how to push it out to the cloud, and viewing the data, that sensor data in the cloud, and using the APIs to pull that data out, and displaying it in graphs and stuff. Okay, so that's going to be next Tuesday. Now, coming up, we've got the next meeting of the WAG. Lester, do you want to talk about that?
Yes, I just need to unmute myself. Thank you, Mike. And if you could bring up the website, that would be great. So we're really excited to have a Washington area Informix user group meeting on June 25th. And this, we're not the only ones having this. Carlton Doe is doing a road show at various cities around the U.S. Where he's doing a one-day technical workshop. It's free on the new features in Informix. The one he says has gotten the most interest. I was actually with him last week. I was teaching a course up in Idaho, and then he came by on Friday to do a road show there with one of our customers. And he said the one that's getting the most interest is multi-tenancy. And that's where you have one big database server, but you run multiple databases on it, like your store. And instead of having a database in each store, you have one database server, and then you have a tenant. Each store is a tenant in this bigger database. So some really exciting things are happening there in Informix, and Carlton will be here to talk about it. So if you could scroll down a little bit on that, I want everybody to see where you sign in. We need to register with IBM if you're coming to this, because IBM is hosting it at their tech center, and they're providing lunch. So if you go to waiug.org, you can sign up, and you got to come in person. But like I said, there are other road shows around the country. And so if you don't come to ours, please go to one of your local road shows. I think you can find all the others at the IIUG, the International Informix User Group website. So now we'll turn open to questions. And the way to ask a question, we found if we unmute everybody, it's sort of chaos. Everybody speaks at once. Hit the chat button. It's in the top right of your screen. and send a chat message. Go ahead and send it to everybody so everybody can see your buttons. And I already had one question from someone saying they wanted to tweet this webcast, and I said fine. And I've been watching on Twitter to see it come alive. Thank you very much, Eric. That's really good. So anybody else, if you have any questions, please type them into the chat button, and Mike will get to them. A good question. Will the PowerPoints be shared? And the answer is yes. Give me about 3 days, definitely by the end of the week, and we should have a YouTube video of this webcast and the PowerPoints available on our website. So you can then download them and share them with everybody else. The one thing you can't do, though, in watching the YouTube video is ask questions. So that's the advantage of coming to this one and the next 4 in person, is then you can ask your questions. Any other questions? I had one, Mike. I was thinking, and maybe this is one that you could probably do an email, and we could add to your slides when we publish them, is sort of what's a list of everything you have to put this together? What are all the pieces? That would be really helpful. So if I was going to build something like this in my backyard, what are all the pieces you used?
Well, it's really quite simple. I mean, all of this stuff is readily available. The Arduino board is the main thing, and then just the cheap temperature sensor is a great way to get started, and just plug that in a similar way that I showed you. And then you need the gateway, and you can get a Raspberry Pi or the Beaglebone as I used, and you could start off just by wiring it directly in, and then very easily you could have a simple temperature sensor sending your data to your Beaglebone or your Raspberry Pi, and then you could install the database on that and start storing that. So you could get up and running very easily. The XBee radios are they're really easy to use, but each one costs about it's about $20 or so. So there's a little bit more expensive to get all set up. Plus, there is a bit of a learning curve there. But they are a great way to get connected wirelessly. And then I know a lot of people are using Bluetooth now for this, so that might be my next thing, is to set up a Raspberry Pi using Bluetooth. But I do like the XBee radios in terms of the mesh network. It's really neat. But yeah, you could get up and running very quickly.
Okay, we have a question about JSON. Mike, can you see this?
Maybe. Can you see? Oh, here we go.
In the chat.
Yeah. All right. Okay, good question.
Repeat the question first so everybody else can hear.
Sorry. I didn't know if this came up or not. So we have a question, whether we use JSON to store any of the data, and how does JSON differ from time series? That's a good question. So even though Informix works extremely well with JSON, and just quickly, I cover this in the next webcast, really. I'll admit that I have not yet used JSON in this example. So I'm storing all of the data in time series, but not in a JSON format. Now, so what's JSON? So JSON allows you to store key value pairs. So we could have a key of like temperature, and then the value, it's 70 degrees. And then maybe another key pair that would be humidity as the key, and then 50% as the value. So that's what JSON would be, is to store those key value pairs. I'm simply storing in time series temperature, humidity, and light. Now, yes, JSON is different from time series, but they do work very well together. So time series, as I'll cover next week, allows you to store very efficiently simple sensor data with a timestamp. So you can say, at this time, I received this value. At this time, I received this value. And it's, instead of being stored as separate records for each of those different readings, they're stored in the same record and just appended to a column. It's a bit of a simplification, but I'll go through this next week in more detail. I won't go into JSON in a lot of detail, but time series I definitely will.
If I could just add my 2 cents there. JSON, because it uses key valued, is going to store more bytes than time series. So a JSON database with this data is probably going to be 10 to 20 times bigger than a time series database. Time series is very efficient in storing this data. And so over time, your JSON database is actually going to end up being slow. And I think that's going to be one of the limitations of it.
But the nice thing is now that you can have JSON within time series. So you can have a time series full of JSON elements. So they do work well together. But again, something I need to play with a little bit more.
So
we've got another
question.
Yes.
Yeah, go ahead,
from
Mike.
Eric. So is the Informix version on the ARM device a full stuff one, or does it have functional limitations? Okay, great question. And I'm really pleased to say that the database running on ARM is a full version. You can run replication on it. You got time series, of course. There are no limitations in terms of functionality. You can run the same database that you would run for your enterprise. There are no limitations. And it will run on, if you download the version for ARM, it will run on an ARM machine. Now, I downloaded the developer edition. That's what I'm running. I mean, there are different editions. Just as there are when you buy the full Informix products, there's different editions, some with limitations, some without. But the full version can run on ARM. That's what I'm running here.
And if I could just add to that, Mike, I think one of the cool things is on ARM, you can have replicating to a full enterprise version of Informix as well. So you could have maybe 200 or 300 little ARM devices all replicating back to one central Informix server. So, and that central server could be the one you have your couple of thousand users querying data on. And do you see the next question, Mike? You want to take it?
I do. Yeah, sure. Does enterprise replication work too? Absolutely, it does. Yep, no limitations. So, and you know, these ARM boards are so cheap. You know, around. I mean, they vary. I mean, whether you're using the Pi or the Beaglebone or whatever. You can just get a couple and start running replication, enterprise replication, or whatever between them. And that's a great thing if you just want to experiment with Informix, experiment with you know, different things that you want to try out. You can just go ahead and do that. I mean, you're not going to break anything. You know, it's better than doing it on your you know, your customer site. So, okay, another question. How about Intel processors? So, yes, you can install Informix on the Intel Quark. We concentrate a lot on the ARM in this example, but yeah, you can install Informix on there too. There's a version for the Quark. Is that your question, Eric, or did I miss it? Okay. Okay, any other questions?
Well, I was going to say, well, time's about up, Mike, so why don't you go ahead and wrap it up? And if there are more questions, oh, there's one last question. Why don't you take that? And then if you have more questions, please feel free to email Mike. His address is on the screen right now.
So this last question, is it true there is an iOS port and Android too? I do not know about that. Lester, have you heard anything about that?
I have heard rumors about that. Go to Carlton. Look for that in the future.
Yeah. I don't believe there's anything available right now. Okay, well, I'm going to wrap this up. Thank you, everybody. Please email me at this address if you want any more information on any of this. And next week's webcast will concentrate on the time series and pushing data out to the cloud. Okay, well, thank you.